Hey guys, welcome to my YouTube channel. Under this lesson, we are going to talk about a topic under Calculus 2, which is sequence and series. Yes, so without wasting much time, we'll dive into the topic very quick as possible. Okay, so what is a sequence? A sequence is a function whose domain is a set of positive natural numbers. Yes, it's a function whose domain is a set of positive natural numbers, which means a sequence is an expression which has the ability to accept input and produce what output. And as it says, the domain is a set of positive numbers, which means the range has to start from 1 to infinity. Yes, the range has to start from 1 to infinity. And when you look at the notation, you realize that we have what curly brackets and a big A and then what a subscript of what of n. Very good. Now a sub n over here represents a what a sequence, or you can also see another thing as what a sub n with the what with the upper part having the infinity side and what the lower part having the what n is equal to 1. This simply means that what with this sequence is starting from what from 1 to what to infinity. You can also have a sequence without the what the actual representation, but in terms of what the list. Yes, so you can have a sequence having the first term, second term, third term, all the way up to what? Up to the nth term. Now, what this is trying to say is that anytime you have a sequence, you can only accept what input starting from what? From 1. And the n over here is moving till the what? Till the nth term. So you are going to replace the n with 1, you are going to replace the n with 2, you are going to replace the n with 3 till infinity. And any natural number you place into the sequence is going to give you a what a subsequent what term. So when you put 1 into what into this sequence, you are going to get a sub 1. When you put 2 into this sequence, you are going to get a sub 2. When you put 3 into this sequence, you are going to get a sub 3, so on and so forth like that. Very good. So let's look at some types of what of sequences. Now you can have what a finite sequence and an infinite what sequence. Now a finite sequence is a sequence that has an end, and an infinite sequence, which will be what we'll be talking about majority of the times, has no what has no end. Very good. So let's look at some examples of how to derive sequences or how to find the formula for sequence. So let's assume we have a what? A sequence. So we have A sub n, which is equal to 3n plus what? Plus 1. So let's assume we have a sequence like this. And we are being what? Told to list. So let's say list the first three terms. Very good. We are being told to list the first three terms. What are we going to do? Now, all we just have to do is what? Is to just, so this is our what? Our function. Now, to get a sub n, it means what? When n is equal to what? Is equal to 1. Are you getting it? So when n is equal to 1, what do we get? We are going to get 3 1 plus what? Plus 1, which is equal to 4. Then you come. When n is equal to 2, we are going to get what? 3 2 plus 1, 3 2 6 plus 1, which is what? 7. And when n is equal to 3, we are going to get what? 3 3 plus 1, which is equal to what? 10. Very good. So you realize that what our sequence or our finite sequence is going to be what? 4 7 and what? And 10. Very good. Now this is going to be the what? The terms of the sequence that we are being asked to find its what? Its terms. Are we okay? So in terms of finding the what? The list or the members of a sequence, all you just have to do is to what? Is to place what? The subsequent natural numbers into the function. So this is the function. Wherever n is 1, when you input it, you are going to get an output of 4, which is going to give you a sub 1. Wherever n is 2, you are going to get what? 7. When n is 3, you are going to get what? This one, and so on and so forth. Yes. So now let's look at how to find the formula of a given sequence. Now, anytime you are being asked to find the formula of a given sequence, the process or the remedy you are supposed to follow is very, very, very what simple. First of all, look at the formula, or let's say look at the sequence very carefully and identify it, whether is it a linear sequence or a fractional sequence or whatever. Now you realize this type of sequence is in the form of a fraction. Are we getting it? Now the second thing you are supposed to what consider is the numerator and the denominator. Now we are also fortunate for this type of sequence. The numerator is just what the same. You realize we are having what we are having one for all. So the next thing we have to look at is the what is the denominator. So when you come to the denominator, you realize the values are what are changing. You have three, you have five, you have seven, you have nine, and you have 11, and so on. So how do you get the formula? Now the first step is to confirm whether this sequence is going to be an arithmetic sequence, whether this sequence is going to be an arithmetic progression, a geometric progression, or something I would love to call the exponential progression. Now, when an or let's say when you have a sequence and it's going to be an arithmetic progression, then it means there is a certain constant difference, which is d, inside the sequence, which means anytime you do subtraction you get the same answer, anytime you do a subtraction you get the same answer. Very good. And if you are also going to get a geometric progression or a geometric sequence, you realize that anytime you divide you are going to get the same ratio, anytime you divide you are going to get the same ratio. So let's look at this sequence. Now you realize that this is the first term, second term, third term, and so on. Now, when you subtract now over here there is going to be one. Are you getting it? Because every number is over one. Now 3 minus 1, we are going to get 2. 5 minus 3, we are going to get 2. 7 minus 5, we are going to get 2. 9 minus 7, we are going to get 2. 11 minus 9, we are going to get 2. Which means the difference is going to be the same. Which means we can easily use our arithmetic progression formula, which is a plus n minus 1 or multiplying with d. Now the a over here stands for the first term. So you realize that the first term over here is going to be 1 plus our n, because we are trying to find the formula, minus 1 or multiplying d. What was d? D was the difference, and the difference was what? Was 2. Very good. So at the end of the day, what do we have? We are going to get 1 plus 2n minus minus 2. And when you do this calculation, you realize that you are going to get 2n. 1 minus 2 is minus 1. So this is going to be the formula of this given sequence of the denominator. Very good. This is going to be the formula of the denominator, and you can prove that. Now when n is 1, 2 1 2 minus 1, you are going to get 1. When n is 2, 2 2 4 minus 1, you are going to get 3. When n is so let's try when n is is 3. Now when n is 3 means when you are trying to find the third term, because the first term n is 1, the second term n is 2, the third term n is 3. So let's see. When n is 3, what do we get? We get 2 multiplying 3 minus minus 1. And 2 3 6 minus 1, which is going to be 5. So you realize that when the n is 3, we are going to get 5. Now all we just have to do right now is to is to represent it very well. So we know that we are having a numerator of 1, because the 1 never changes, and the denominator is going to be 2n minus 1. Very, very simple, and we are done.